Okay, so we have section 1.4. This is called complex numbers. So with complex numbers, we're going to have to, of course, note the definition of them, how to use them. We're actually going to look at multiplication and addition and subtraction of complex numbers. Also, we're going to be looking at division, okay? And I would like to add that at the end of this lecture, on the last slide, that there is a extra credit assignment that you can do that's actually due before Unit 2 test, and I will write that on the notes themselves. Okay, so to get started, notice there are these little yellow boxes here. These yellow boxes contain the definition of an imaginary unit I. Okay, so when we talk about imaginary units, we talk about square roots of negative numbers. So notice that an imaginary unit, meaning not real, is denoted with this square root of -1. And this is called I. So by definition, this right here will always remain true. Okay, so it's the square root of -1. All right, so a lot of times what happens, and this is actually just so that you know about imaginary numbers, let me go ahead and just add a quick slide right here. So to kind of get your mind going on a couple of things. When we take the square root of 9, we know that that is 3, because we know that 3 times 3 equals 9. Okay, so remember that by definition of a square root, we need to multiply two numbers to be that number underneath the radical as well. So say, for example, if we were trying to find something like -1, well, this would have to equal I, because what's going to happen is that there is nothing underneath this radical that you can multiply together to be -1. If you multiplied two negative ones together, that would give you a positive 1. If you multiplied two positive ones together, that would still give you a positive 1. So by definition, this is always going to be true. Okay, so let's go back here and look at the other part of it. Now, also here, notice that this I squared is equal to -1. And this is how we get that. So going over here to our little side note blank sheet, that if we were to take this, if we were to say that, yes, we know that I equals the square root of -1, notice that if we squared both sides, we would have I squared equals -1. And here's the reason why. Because there is this square root here, and there's this 2 right here, notice that those two cancel each other out. So, and if you're kind of questioning, well, why did those cancel each other out? It's because that, say, if we had square root of 9 squared. Notice that the square always cancels with the root. Okay, so even if you had something like square root 3, and even squared underneath, that too, with this radical, is going to cancel as well. 3. So whatever happens, if the 2 is underneath the radical or the 2 is outside the radical, those are going to cancel each other. Okay. All right. So here, knowing this, let's look at the other part. It says the complex numbers and imaginary numbers. Okay. So complex, we've got something called a complex number and imaginary number. So all of these are imaginary numbers. We do have a complex plane. The imaginary numbers consist of a real part, which is this A, and the imaginary part, which is that B. Okay, so Remember though, in this particular expression, when we have this -4 minus 2i, -4 is going to be our a, and our b is going to be -2. Notice it's not -2i, because the b is this -2, the I is separate from it, okay? So if I were to write it just up above, I'd have A plus BI. Note that my A would be my -4 and my B, including that sign in front, would be the -2. And notice the I's aren't included at all. So if you're asked what A is, you would say -4. If you are asked what B is, you would say -2. Now, just so you know where these numbers actually lie, I'm going to show you what they look like graphically. Okay. So here's our graph of the complex plane. And if you want to, you could write C here with a slash through the side to denote that it's a complex number. So complex plane. And beforehand, what we've noticed about a plane is that we had an X and a Y. Well, now we have an A plus a B, I. Okay. So that's what an actual point looks like in the complex plane. So here is the real axis, what we would denote as RE. Here's the imaginary axis that we would denote as IM. So if we had a point, say if we had this point -3 plus 2i, and we had to plot this. Okay? So if we had to plot this, what we would do is note that this is our real part, and this too is our imaginary part. So y'all, we go over 3 spaces backwards on the real axis here, and then go up 2 spaces on the imaginary axis. So here's our point, -3 plus 2i. Okay. So that's just how a number looks on a plane. I just want you to know that you won't have to graph it, but however, it's just kind of good to know to have a picture of it, of what it looks like in your head. Now, if you are to move on to take pre-calculus, you will definitely have to know where this is located at. So it's definitely suggested that you keep this in your memory. Okay. All right. So to sum up so far, remember, importantly, is that we have the square root of -1 being I. I squared, by definition, is always -1. Complex numbers and imaginary numbers, note that it has a real part A and it has an imaginary part B. Do not include I if you're just asked what B is. Okay. So let's go back and refresh, and let's just start from square one with going from simplifying these expressions to multiplying and then dividing them. Okay, so by definition, we already know that the square root of -1 is simply denoted as I. I squared, we know as -1. And the reason why this is because we have I squared, which we know it to be -1, and then squared, remember the 2 cancels out with that square root, leaving us with just whatever's underneath it. Okay. All right, now we have this -I squared. Well, remember, I squared is -1, so if I substitute that -1 in for the I squared, it becomes +1. Okay, so square root of -36. Square root of -36, when you're simplifying square roots, anything with a square root, you will always want to split it up into factors. And you want to make one of those factors a perfect square. And remember, a perfect square is when you multiply something together, okay? Like 2 times 2 equals 4. 4 is a perfect square. 3 times 3 equals 9. 9 is a perfect square. 4 times 4 equals 16. 16 is a perfect square, and so on. Okay, so here when we look at 36, we're like, okay, well, can I split 36 up into a perfect square? And you're like, well, I can, because 36 itself is a perfect square. So I can go ahead and say that this is the square root of 36 times the square root of -1. And so the square root of 36 equals 6, and then the square root of -1 we know by definition as I. So this is 6I. For this next one, -64, we start thinking to ourselves, well, we can split up -64 into a perfect square, because we can say that 64 itself is a perfect square. So we have negative square root 64 times square root -1. And remember, I'm doing this because -1 times 64 still equals -64. Okay. So negative, and then the square root of 64 is 8, because 8 times 8 equals 64. And so the square root of -1 equals I. Okay, so now, kind of adding some stuff onto this, let's take each one of these and simplify each one of these terms. Okay, so we have the square root of -81, and so we know that, actually, if we went over here on the side, just kind of our scratch paper, you know that the square root of -81 is equal to square root 81 times the square root of -1. So square root 81 is 9, and then we have I with it. Okay, so we have 9I, and then minus, and the square root of -144 is actually 12. Okay. So note that the square root of 144 is 12. The negative portion underneath here is I. And so notice, we can actually subtract these two numbers because we have the same base and the same exponent. So we have the I here as the same base, and we have 1 as the exponent, so we actually can go ahead and say 9 minus 12, and then preserve this I. So we've got -3I. So for this next one, if I were to go ahead and multiply this negative through here, so I can go ahead and get rid of some parentheses, I simply have -7 plus 5I plus 9 plus 11I. So here I've got plus 9 and -7 add together to be +2. 5I plus 11I added together equals 16I. Okay, so just so you know that before we leave this page, we're just going to practice finding A and finding B. Okay, so finding A, if I were to look at this could also be written as 0 minus 3I. So A equals 0, my B equals -3. Okay. So remember, with B, you don't want I with it. For this one, notice that my A is equal to 2, and my B is equal to +16. And again, you don't have to write this for every single one of them, but it is good to know what is A and what is B exactly. Okay, so now multiplication. So it says here to perform the indicated operations and write the result in standard form. Okay. I can already tell you right now, we're going to probably need a little bit of room. Okay, so we've got to multiply this through, just using our distributive property like we normally would for anything, we've got negative 8i times 2i gives us negative 16i n squared. Negative 8i times negative 7 give me positive 56i. Now this is really important, you guys. Notice that this I squared here, y'all remember what that was? If you guessed negative 1, you are correct. So you've got negative 16 times negative 1 plus 56i. And of course, negative 16 times negative 1 gives you a positive 16 plus the 56i. So in this scenario, our A is equal to 16, our B is equal to 56. Notice on this one, we actually have to FOIL out. Y'all remember the first, outer, inner, and then last. So remember we have to multiply those out. So let's go together and let's try this out. So we've got 8 times negative 3 equals negative 24. And 8 times 9i gives me plus 72i. Negative 4i times negative 3 gives me plus 12i. Negative 4i plus 9i minus 36i squared. So remember they have those little i's there. So you've got I squared, you've got 2 of them. So simplifying this, I can take this portion here and say, oh, I've got 72i plus 12i. That gives me 84i. And I'm just going to simply bring this negative 24 down. So I have negative 24 plus 84i minus 36. And remember, I squared equals negative 1. This negative 24 plus 84i and then plus a 36. So now you have negative 24 plus 36. That turns out to be 12. So I have 12 plus 84i. And notice I wrote it this way because it's in that form a plus bi, right? So my a in this scenario is 12. My b is going to be 84. So once again, I just simply multiply this through. So negative 7 times negative 7 equals positive 49. This negative 7 times I minus 7i. Negative I times negative 7 gives us a plus 7i. Negative I times an I gives us minus, let me change that real quick, minus I squared. Note that when I simplify this negative 7i plus 7i, those cancel out to 0. So here I've got 49, and then remember that I squared turns out to be a negative 1, so I have minus a negative 1. And this is 50. Well, that's interesting. There is no I in this at all. And we'll come back to this momentarily. I'm going to show y'all something special about this. If you want to, you can write it as 50 plus 0i and say that A equals 50 and then B equals 0 if you would like to. So just so you know that if you are asked what B is on something like this, B would be 0. It's completely 0. Okay, so for this one, y'all remember, and I'm going to go ahead and insert another little page here and just put reminders. If y'all had something like this, x minus 3 squared, remember that it actually equals x minus 3 times x minus 3. And when you actually do all the FOILing to this out, you have x squared minus 3x minus another 3x plus 9, which notice that you have this middle term here. It's negative 6x plus 9, okay? So x minus 3 squared, you have to be really, really careful. It does not equal x squared minus 9, okay? Careful on this. Be really careful on this. A lot of people end up making this mistake. Don't let it be you. So with something like this means that I actually have to write this out. 5 minus 2i times 5 minus 2i. And of course, all I do is just simply multiply it like we've been doing from the first, which got 25, the outer, which would be negative 10i. The inner is also negative 10i, and the last is plus 4i squared. This negative 10 and this negative 10 together, they do not cancel out. They actually add together to be 20. And then this I squared, remember, is a negative 1. So 25 minus 20i plus 4 turns out to be 29 minus 20i. And so here, if you were asked, your A is going to be equal to 29, and your B is going to be equal to 20. Move this down here so we can talk about that other one momentarily. Okay, so when you see this square root, the first thing that I want y'all to do is that I want y'all to make this into the I portion, okay? And keep the square root as is. Okay. So what I want you to know is that I want you to do this. I've got negative 3 minus, and then square root 7, and then I'm going to put my I way out there. So notice you don't have to deal with an extra negative on something, okay? So be very careful with this. So when you write this out, make sure that because of the square here, you've got negative 3 minus the square root, so times I, and negative 3 minus the square root, 7 times I. And so now, once again, the first turns out to be 9. The outer two turn out to be positive 3 square root 7i. The inner two turn out to be positive 3 square root 7i. And then the last two, remember we've got square root 7 times square root 7. Which is square root 7 squared. And then we got I times I, which is I squared. Well, first of all, I know that I can go ahead and add these two together. So I've got 9 plus 6 square root 7i. And then note that I have square root 7 squared, so that square cancel out with the square root. That gives me 7. So remember, squares and square roots cancel out. And I have this I squared here that turns out to be, if I can get my pen to keep looking for us. And it turns out to be negative 1. So now I have 9 plus 6 square root 7i minus 7. So that equals, here I've got those two. So I've got 2 plus 6 square root 7i. And y'all, that was the longest, hardest one. So here I've got my a equaling 2, my b equaling 6 square root 7. If you're asked that. So just want you to know, as far as I'm concerned, this is your answer when you're multiplying all of this stuff together here. Okay, so back to these. All of these, notice, had an I here. So notice all of them ended up with an I. The only one that didn't end up with an I is this one right here. And there's a reason why it didn't end up with an I in this. Okay? The reason is, if we go back to our little reminder page, that if we had x plus 3, and this is just some kind of random example, x plus 3 times x minus 3, note that if I multiply this together, I'd have x squared minus 3x plus 3x minus 9. And those will cancel out in the middle. What this is called is a difference of two squares. Okay, so you guys remember that this formula holds true. Whoops, not a to the b. Y'all don't want to see anything like that craziness, but you do want to see this. You want to note that a squared minus b squared equals a plus b times, well, a minus b. Okay. And same scenario, you can switch it around the opposite way. A plus b times a minus b equals a squared minus b squared. Okay, so let's use this, all of this down here, to denote what goes on with those difference of squares with imaginary numbers. Okay, so what we're going to do is we're going to take a peek at this. If you had imaginary number, say if you had a plus bi times a minus bi, okay? So when you do that, note that when you multiply this through, you're going to get your a squared, your a times your negative bi, which is negative a bi. These two multiply together, which is a bi. And then the last two multiply together, which is plus, oops, not plus, minus b squared I squared. Okay. So notice that these cancel out into nothing. Anytime that you have a difference of squares, the stuff in the middle is going to go away. So you have a squared, and then minus b squared. And then remember that I is what? Yes, negative 1. You are correct. So we have a squared plus b squared, which is all of this stuff here. And notice, do y'all see any I anymore anywhere? No, you do not. So this whole entire thing is completely real. There is no imaginary part. There is no I to follow it or anything like that. So let's utilize this idea, okay? So let's go back to this problem. Instead of having to multiply everything out, we could use a shortcut, okay? And here's the shortcut for this. You can say that a plus bi times a minus bi equals a squared plus b squared. Okay, so this means that in the beginning, if we're given something like this, where we have a negative 7 minus I times negative 7 plus I, we notice that first of all, these two signs, this negative and this positive, are opposite of each other. So what we can do is, instead of multiplying everything out, we can just use the fact that we know what our A is and we know what our B is. So here we could say that we have our first, which is negative 7. If we square this A here, we've got 49. If we square the B, we've got plus 1, and that just gives us 50. Okay. So if we need to, we will definitely be going over this in class, okay, and trying some more examples. All right, so for our next one, we need to divide and express, the result in standard form, okay? So remember, in standard form, it's A plus BI so we have to make sure that it looks exactly like this. So the main idea with this is that before we start doing any of these things, we want to look at what a conjugate is. I'm going to add another little folder in here. Conjugates mean just to switch the sign in the middle, okay? So this means if I were given something like 3 plus 5i, then the conjugate would be 3 minus 5i. If I had negative 7 minus I would have negative 7 plus I. If I had negative 5 plus 2i, I would have negative 5 minus 2i. If I had 6, the conjugate would still be 6. If I had negative 6i, the conjugate would be positive 6i. And it's all based on the fact that we have these zeros hidden here. So we could say minus 0i here. It wouldn't change the fact, though, that there's no difference between plus and minus 0. Here, notice that no difference. Okay, so notice it doesn't matter what sign is at the very beginning, our A portion, but our sign in the end, in the middle, that's what we switch. Okay, so again, don't switch the front guys, just switch the second ones. Okay, so when we multiply both top and bottom, meaning both numerator and denominator, find the conjugate of the denominator, notice that that I is going to go away, and you start to ask why. And it's basically because we have the difference of two squares in the denominator. Okay, so here, remember, your main step in this is multiply the denominator, multiply the numerator and denominator by the conjugate of denominator. So what I'm going to do is, first I'm going to give myself some room and make some room for this one. So what I'm going to do is I'm going to go ahead and say, all right, well, I have to multiply this by something. And I know I have to multiply the numerator, and I have to multiply the denominator by the conjugate of this denominator. So the conjugate of that denominator is 2 plus I. So 2 plus I. So when I multiply this through, I have this 5i times 2, which creates a 10i. 5i times I plus 5i squared, all divided by, and y'all remember our shortcut? Our first is 2, so I've got 2 squared, which is 4. And then I've got the second square, which is negative 1 squared, or positive 1 squared, it doesn't even matter, plus 1. So that turns out to be 10i plus 5 times negative 1 all over 5. So then this turns out to be 10i minus 5 all over 5. And note that it still doesn't look like in this form, it still doesn't have that I in the very end. So we're going to have to go ahead and split this fraction up. So this is a trick here. This is a really good trick. Split the fraction up and simplify each term. So you have 10 over 5 times I minus 5 over 5. And so now I have 2i minus 1. And this still does not look like a plus bi, so that means that I have to switch these things around because I want the I in the end. So now I have negative 1. Remember to take the sign out in front. So you have negative 1 plus 2i. And that's in the form of a plus bi. Okay. So this is in standard form. This is not in standard form. Neither is this. So none of this is in standard form until it gets down to here to where you have an a, which would be negative 1, plus my b, which is 2, and times I. Now remember, all of this stuff here is my nice little shortcut. So remember, take the first, square it. 2 times 2 is 4. Take the second, square it. Negative 1 times negative 1 is 1. That's always going to be positive, and that will always be your denominator. So let's try this one. I guess I'll do it in a different color. So y'all, what's the conjugate of the denominator? Yes. And denominator by that. So now I have 3 times 4. And notice these look similar, but they're not conjugates of each other. So I've got 3 times 4, which is 12. So nothing's going to cancel out in the middle. 3 times negative 3i, which turns out to be negative 9i. Negative 4i times 4 gives me negative 16i. Negative 4 times negative 3i gives me positive 16i, all divided by, and notice that these two are conjugates of each other. So what happens is that we can use our shortcut. So the first squared, 4 times 4 is 16. The second squared, 3 times 3 is 9. So that's really nice. Oh, I forgot my I squared at the very end of this statement. Why did I write 16? I must have been getting ahead of myself. Okay, just for fun, we'll go back over this. 3 times 4, 12. 3 times negative 3i, negative 9i. Negative 4 times 4, negative 16i. And then negative 4 times negative 3i gives me a plus 12 and an I squared. Okay. All right, so here we've got 12, and then notice that this is, looks like to be negative 25. And then plus 12 times negative 1 all over 25. And notice that all this stuff here looks like that's going to be negative 12. So I actually have 12 minus 25i minus 12 all over 25. So this 12 and then that 12 cancel because they're on the same side of the equal sign and they have opposite signs. And so I have negative 25i divided by 25, which equals negative I. And that's it. That whole entire thing was just negative I, which we divided those through. Okay, so here for our challenge for the day, remember that this is going to be your extra credit. This is due on the day of Unit 2 test. So remember, this section 1.4 is in Unit 2, okay? So this is due on the day of Unit 2 test at the beginning of class. All right. Okay, so make sure you write this down or either print this page out, do the problem, and then send it in. So if you have any questions about any of these slides, please contact me through email. I'd be happy to go over them with you. If you should have any questions about your homework, definitely click on Ask the Instructor button, and so that way I can see your actual solution that you put into MyLabs Plus and see if I can help you that way. So anyways, I hope you all have enjoyed this section, and let me know if you have any problems at all. Have a great day.